Hello guys, welcome to the video of new house price prediction using linear regression. This is Arun from PANIMALAR Engineering College and this project is made under the guidelines provided by Skyfi Labs. So the prime aim of this problem statement is to predict the prices of houses in Boston with the help of Boston House dataset. This Boston House dataset was being designated in the year of 1978 with 506 entries and 14 features right from LSTAT, CRIM, and so on. So this linear regression process can be broadly categorized into five types, namely data pre-processing, normalization, splitting of the datasets, training of those datasets, and prediction. So first and foremost thing is to import the libraries required for the model preparation. Any model has to be prepared should consist of a target, and for that target we have to first of all import the Boston House dataset from sklearn library. So after importing this Boston House dataset, it is essential to call the function called feature. So feature is nothing but it enables us to know what were the attributes that Boston House datasets were consisting of. And after calling out the function feature, it is important to call out the function called target. And this target is nothing but the values or the variables in which this has to be compared with the other variable that deviates from it independently. So after calling out this target function, it is important to concatenate this target with other attributes of the Boston House datasets as shown here. So here the target value has been concatenated with other attributes as shown. So after concatenating the target with other attributes, it is important to visualize the target relation with other attributes. So as we infer from this graph, we could see that attributes and target are varying with each other with the respective numerical values. We could infer that LSTAT is so sensible with that of the correlation with target. Here, this denotes that the value of LSTAT should be normalized with the correlation of the target. Hence, normalization process is taken place. So we could see the normalized values after this normalization function. So after the normalization function, here comes the process called splitting of the datasets. So splitting of the datasets is done based upon the training dataset and testing dataset. So the training dataset is comprised of 80% of the data and remaining 20 is the testing dataset. So after all these functions, we have to cut off the error from these datasets. So it is important to use two functions, namely update function and the gradient descent function. So in both these functions, the method called mean squared error average is followed. So after this, we have to visualize the data sets represented by the pictorial representation. So it is necessary to use the function animation or something else. But unfortunately, the animation function is not supported in this module. But we could see the graph representing that red line is known as the linear variation of the data with training data, and these blue dots are the expected training y value, that is nothing but the expected target value. And also we could observe that the error or the plotting of error is decreasing at some point and it also varies with iterations. At last, finally, in the process of prediction, we could easily arrive the target y and the predicted y, which is nothing but the target y is nothing but the price of the house in dollars or something, and this predicted y is the predicted value of the house in dollars. And that's about linear regression in Boston house pricing. Thank you for your time and considerations. Thank you.